Well, so I have Permagrin right here. I got home from work and had a wonderful surprise. The painting is completely finished in the kitchen, and Jim and the painter moved some of the furniture back in place. There's still a lot of cleaning and dusting that has to be done, but I would like for Jim to just kind of pan around and show you a glimpse of what our kitchen now looks like with this fresh paint. So this is one of my favorite spots in the whole house right now, in front of our red bay window. Don't mind the blinds. We have work to do on them. They're a little bit crooked. And so the walls are a very light tan, picks up some of the color of the red, and then it works all the way around into the breakfast room. And we still have a lot of work to do, but this is such a huge step, and it has just lifted my spirits. I am pretty happy. This is really fun. And so welcome to Rose Red Homestead. And today we are going to take off in a little bit of a different direction. This is all about self-reliance, food security, and emergency preparedness. But we're done with off-grid for a while and are going to focus more on food storage and other things that are of great importance to us right in this moment. And today we're going to talk about amino acids and food storage and what the connection between the two is. Over the break, I took all of last week off. Not only did I need to work on our off-grid Thanksgiving dinner, but I just needed a break from the university. I have about 3 weeks left, and I just needed to get away from it and get my perspective, help in the kitchen a little bit. And I did a lot of research on amino acids and proteins and how important they are. And I want to explain it in what I hope is a simple way so that we can understand the critical importance of making sure that the foods that we store for times when we might not have the availability of foods the way we have right now, that they contain enough of the amino acids that are required for our bodies to have its normal function. So what is an amino acid anyway? Well, it is a molecule made up of certain elements, and there are hundreds of them in nature, which was something new to me. I did not know that there were that many. My doctorate is in science, but it is in particularly plant ecology is my area of specialization. My doctorate is in science education, but my science knowledge is about plants. But I love all science, and so I did a lot of reading, and it was just so intriguing to me, and I hope to share some of that passion with you today to help with what we're trying to do with food security. So these molecules that are known as amino acids, hundreds of them in nature, we really are very laser focused on only 20, because that's what our body needs to do its work in all kinds of areas, which I'll explain to you in just a minute. Amino acids are the building blocks of proteins. And one of the scientific articles that I looked at was from the Cleveland Clinic. And I love the metaphor that they used for amino acids and protein. They said to think about amino acids as letters in an alphabet. And you can put those letters together in lots of different configurations to make different words, short words, long words. And that's a perfect metaphor for what happens with protein. So the amino acids, these 20 amino acids that our bodies need, are like the raw materials, like the letters of the alphabet. And they then are put together by our bodies in various ways in long strings of these amino acid molecules that then make up a protein. And our body makes dozens of different kinds of proteins. And the shapes of the different proteins are different chemically, and their function is different. So let's dig into those 20 just a little bit. The really cool thing is that of those 20, our bodies, with the raw materials that are already in our bodies, they can manufacture 11, all on their own. We don't need to worry about diet for those 11 because our bodies take care of those itself. But the other 9, that is a very different story, and those are the ones that we are especially concerned about. So, among those 20 amino acids, there are the 11 non-essential, and the reason that they're called non-essential is because it is not essential for us to even think about them, because our body does the work for that. The essential amino acids are these 9 right here. And I'm going to pronounce these for you. I love scientific vocabulary, so I'm just going to say these for you. But know that we don't need to memorize these. We don't need to know them, but I think I'm just going to read them to you one time. Histidine, isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan, and valine. These are the ones that we need to take into our bodies every single day. If a food contains all 9 of these, we call that food a complete protein. If some are missing, whichever ones, then it is an incomplete protein. We need complete protein every single day. But do we have to focus strictly on foods that give us that complete protein? No, because what we can do, if we know our foods, and we're going to get there in just a minute, I'm going to hopefully share with you an easy way to configure that in your mind. We can mix and match different foods and put them together so that in combination, they will form a complete protein. All right, so what do these amino acids do for us anyway? Now, I have made a little 2-page, I'm calling this an info sheet, and I am uploading this to our website, and the link to our website will be below this description of the video. And just go to the website. When it opens up to our home page, scroll all the way to the bottom where I have a list of downloads. It's a free download. So you can, if you were in my class at the university, this would be a handout that I would give to you. So consider this a handout that you can download and then print out and put in your notebook that you are putting together for emergency preparedness. So what do amino acids do? This little chart that is in your info sheet is from the Cleveland Clinic, and I'm just going to read from that. Amino acids break down food, grow and repair body tissue, make hormones and brain chemicals, provide an energy source, maintain healthy skin, hair, and nails, build muscle, boost your immune system, sustain a normal digestive system. So the thing that is, to me, just elegant, you know, sometimes things in science just almost give me goosebumps, and this is one of them. It is so elegant the way this works. So our body can produce 11. We put the other 9 in, and then our body puts these together in these long strings of proteins. And some of the proteins do one function, some do another function. They all have different functions, hundreds of different functions proteins do in every cell of our body. But then the economy of protein metabolism is such that our body can then break those strings of protein down into the amino acids again and reconfigure them. And some of them get used up. That's why we constantly need every day to put those 9 essential amino acids into our bodies so that the building blocks for protein are always there and always ready to go. So, what do we need to think about with food storage? We need to think about storing foods for midterm and long term that contain all of the amino acids that are necessary for us. Now, on the second page of your info sheet, I have a little table, and you won't be able to read it here, but let me just explain to you what it is. It has 4 columns. In one column, it lists foods that are complete proteins, and those include dairy, eggs, poultry, beef, pork, fish, mushrooms, and from the plant family, mushrooms, quinoa, amaranth, and buckwheat. Those all have complete protein. Then I have these 3 columns, And these 3 columns are all incomplete proteins. But here's the thing. In 3 columns, you can take 1 from one column and 1 from any other column. So you have 2 foods combined from 2 different columns. Together, they make a complete protein. Because these family groups are nuts and seeds. Nuts and seeds all have sort of the same configuration, the same incomplete number from the 9, but they have about the same ones. So do legumes. That's the second family. That's peas and beans. And then the third family is the grains: wheat, rye, oats, corn, barley. And so it is combining those together that form the complete protein. Now, one of the things that I give you in the info sheet is an example. So what if you had cereal for breakfast, beans for lunch, and a meat dish for supper? All right, well, cereal is not a complete protein. And you had that for breakfast, but for lunch you had beans. So that's 1 from the cereal family column, 1 from the bean family column. Together, they have made a complete protein for your body. So you don't need to consume a complete protein at every meal, so long as throughout the day you combine foods in such a way that you do have complete protein. Now, the meat dish in the evening for the evening meal is complete all on its own. So that makes it very nice. But notice how easy it would be to revisit that breakfast. You have cereal, that's from 1 column. So what could you add to the cereal to make it a complete protein? Well, you could add milk, which is a complete protein all in and of itself. So for beans, what could you add? Well, you could add a tortilla, you could add a piece of bread, you could add a glass of milk, and so it is the mixing and matching. All right, so these are foods that then we can store in our food storage that will give us the amino acids that we need. So these are examples of foods that you can store long term to have the protein and the amino acids that are needed. So just a couple of things before we get into the foods that I have set out here. There is some concern in the medical community that we as Americans are so concerned on protein that a lot of people are taking in too much protein into their bodies. So how much protein do we need? Well, according to dietary guidelines published by a national council, we need about 15 to 30 grams of protein per meal. And we for sure need to get a doctor's opinion for our own health concerns if we decide to add any supplements. Protein supplements, dietary supplements are a multi-billion-dollar industry. And frankly, I'm not about to contribute to the profits in that industry because for the most part, we can get all of the nutrition we need from good food. And we can avoid the processed and over-processed foods if we will store raw ingredients and then put the food together for ourselves. And I know that not everybody can do that, but we can start in some ways using more foods that we prepare meals from scratch rather than getting it out of a box or a can, using fresh ingredients and single ingredients. So that's my kind of spiel today. I do not take dietary protein. If you take in too much protein, it can be really hard on your kidneys. And so if you have a propensity toward kidney disease or difficulty with your kidneys, watch your protein intake and just be very, very cautious. So I've pulled today some examples from our food storage and I've lined them up in the columns that are on that paper. So let's look at examples of foods that we can store, and I store these for long-term storage But we rotate through, as you all know, we rotate through our storage, and so I'm using these constantly in the meals that I make. So over here are the complete proteins, and we have quinoa. And there's also a big argument over which is the best protein. Is it plant protein or is it animal protein? And there was a great medical study done that I read from a university, and I can't remember. It's a prestigious university that I can't remember which one it is, where they tested all of those functions that I read off of the little chart on people that only consumed animal protein compared to people that consumed plant protein, and there was no significant statistical difference in the outcomes on both of the groups. The only difference is that animal protein tends to be complete protein. And you know what? What the supplement people don't want you to know is that your body doesn't care where the amino acids come from. Whether those amino acids come from jelly beans or butternut squash, your body doesn't care, as long as it is the amino acid that it can use. Now, here's the difference. Proteins come packaged with other things, like, for instance, beef. The protein in beef is packaged in that meat along with a whole lot of extra fat. And so you're going to have more calories if you focus on just getting your complete protein from beef. If you choose a donut that's made with wheat flour, that carries a lot of extra carbs and a lot of extra sugars. And so we just need to watch how our protein is packaged and keep it as clean as we possibly can. So quinoa is a great source of complete protein, and it is from the cereal family, and it is a seed actually. It's a pseudo cereal because it is a seed and not actually a cereal, but it's right over here in the complete protein. Now, I cleaned out my cupboard at work where I stored my emergency food at work, and I had a bunch of these little foil packages of tuna. This is a complete protein, and it's a great one. Here is a pint of chicken that I have canned, and here is a quart of turkey soup. All of these would make meals that have complete protein. Also, you can buy it in cans. This is salmon, this is tuna. We're all familiar with these cans, so these are really great food storage items. So this is the column for complete protein, and this is just a sampling of what is possible to store in our food storage to get the amino acids that we need. Next is nuts and seeds. So here are my pecans. So let me turn them this way so you can see the sign. And I keep a big package of these going all the time. I go through them really fast. I eat these for snacks. It's a great high protein snack. And nuts are best kept in a freezer, and they only store for about 6 months. We rotate through them more quickly than that. Peanut butter, we're all familiar with this one. So a peanut butter sandwich, which takes peanuts from this column and grain from the bread to make the flour in the grain column, and there's a complete protein right there. And then I just realized that this salad topper that I've been talking about in several videos is mostly pumpkin seeds and sunflower seeds. And so this is great to get extra protein, and this is again just in one column. But you could throw it, I could throw some in this soup for extra protein if I wanted to. This column is beans and legumes, beans and peas. And I brought out black beans because black beans are very high in protein and very nutritious, but all beans work right here. Here are lentils. These are yellow lentils. I use these to make our rainbow lentil soup, which we've done a video on. And then even in a can, buy a can, but now this has been processed. I just want to share with you now, I just bought some garbanzo beans. In a recent video, we unpacked those beans and put them in our buckets for storage. But and so I prefer to make them from dry beans. But once in a while, we find a good buy on cans and we'll buy them. But listen to the ingredients in this can. Prepared garbanzo beans, water, salt, sodium Metabiscoplop. That made the cameraman laugh. And calcium disodium eta to promote and protect the color. Now, when I can garbanzo beans, it will be beans and water, period. And so I don't worry about all that stuff I can't pronounce. That's why it is far better for us to make our things from scratch from a single ingredient when we can do that. The last column is the grains. And that includes wheat and oats and rye and corn, and I have rice back here. And then, of course, all of the flours that we make from these, oat flour or corn flour, wheat flour, all of those also are in this category as well. And so it becomes a fairly simple process if you have this little chart to pick one from one column and one from a second column to make a complete protein. They're called complementary because they patch each other's holes, and all 9 amino acids are found there when you combine 2 from each of 2 different. And you can put 3 together, it doesn't matter, you can do that as well. But this will help us when we are putting our food storage together to ensure that we have the building blocks of protein which we need for survival. We are going to talk in future videos about ancient grains, and there's a lot of hype about ancient grains right now. We're going to dissect that just a little bit, just like we've kind of dissected amino acids and proteins today, but this is foundational. This information is foundational for what we're going to need to know as we move into ancient grains going forward. So I'm looking forward to new adventures as we finish up the holiday season and go into spring, when the growing season will start before we know it. So thank you for being with us. We appreciate you so very much. And just one little note, when Jim and I decided, after the marvelous success of our Black Friday sale, which we want to thank you for again and again and again, Jim said, I want my birthday sale to last for 2 days because I want people to have more opportunity to get the information that we have. So coming up in December, Jim's birthday is 2 days after Christmas, he is going to hold a 2-day sale from all of the books in our bookstore, so to give people more of an opportunity. I haven't decided what I'm going to do for my birthday sale in August, so we'll take that when it comes. So thanks again for being with us, and we'll see you at our next video.